What should you do first? What should we do? Yeah, distribute the exponents in, so you get x to the 1/4, y to the 1/4, x to the y to the. Now what do you do? Yeah. So it becomes x to the 5/4 and y to the 5/4. Sure. Absolutely. Good job. Can you simplify that a little further? There's one thing you could do. You could turn it into xy to the 5/4. It's debatable whether which one is most simplified. Jess? Wait. Got it? Did that click?
Yeah, no, I got the, I don't know, I guess I just added one.
It's the simple mistakes that kill you on these. It's definitely the simple mistakes. That's fine. Okay, any others? Quiet. Shh, quiet. Any others on any of the ones you've done in this packet? Anything? Anything? Right here? 45, right here. Okay, so what's annoying about 45? What's annoying about this one? Is that the one you want to do? Oh, not that one? Okay, not that one. That's fine. Not that one? You mean this page right here?
Yeah.
45, sure. What's annoying about that one? Fraction. You don't like fractions. What do you do with the power? Distribute it in, so it's 16 to the what power? X to the what power? 2 times 3/4. We'll leave it like that for now. Y to the negative 1/3 times. Yeah, you multiply the powers, right? What does 16 to the 3/4 mean? Can someone say it out loud? What? 4th root of 16 to the... Yeah, you could do this. This is one way to think about it. 4th root of 16 to the 3rd power. X to the what power? Y to the... What's the 4th root of 16? So 8 times x to the 3/2 over what? Y to the 1/4. So y to the 1/4. Now, just let me just finish this real quick. That would be totally acceptable as an answer. I don't really like fractional exponents in the denominator, but if you just had to write it in powers, that's fine. You could rewrite it like this: 8 times the square root of x to the 3rd over what? Over what? 4th root of y. That's another way to write it. Either one is okay. This is fine, though. Yes, what's your question now? Can it be what? -8? No. Think about it as it's only the principal root because the rooting is already there. You're not adding in the 4th root. The 4th root is already there. So take the principal root, okay? Just take the positive. Any others from what you worked on last night? Any others? Okay, I would like you to pick the 5 that you think look the worst, and then do those 5. It's a good thing to do first. Hold on a sec. Yep, distribute the exponents. Absolutely. You could do that. What types of numbers do I not like, though? Yeah, no, let's distribute the exponents first. That's fine. That's a good default thing to do first. That's fine. So you get 4x to the -2, y to the -1, z to the -1 over 25, x to the 4th, y squared, z to the -2. Now what? Yeah. Yeah, same base you subtract. So you end up with 4x to the -2 minus 4, y to the -1 minus 2, z to the -1 minus -2, thank you. Minus -2 all over 25, sure. So that's 4x to the y to the -3, right? Z to the all over. I don't really like negative exponents, so what am I going to do with those exponents that are negative? Flip it down. 4z to the 1st over 25 x to the 6th y cubed. That's a great thing to leave it as. And you don't need to write that z to the first, but you can if you want. That's a great way to leave it. You could leave it as, you can leave negative exponents in there if it allows it. There's no hard and fast rule that says one is better than the other. Just as an alternate method, just an alternate order, I tend to go after the negative exponents first. That's what I like to think of in my head. I mean, you'll do these so often, and you have done them so often, that you should be able to do most of it kind of by feel. You should see what direction to go in. I like getting rid of negative exponents first. That's one thing I can do. So if you just wanted to get rid of z to the negative 2, where can you put it and make it positive? You can just march it up top and make it z squared, right? You could march it up and make it z squared. Absolutely. So 49, what's the only thing that 49 really adds in? A little more fractions, right? So let's talk about getting rid of that negative first. What's one simple thing I could do to get rid of that negative and just make it 2? Y over x. You can just flip it over, right? Yeah. Times y to the 4th over x to the 4th over x squared y cubed. What do I do with that other, what do I do with this one now? Yep, distribute the power. So y squared, y to the 4th over x times x to the 4th all over x squared y cubed. So what does that turn into? Well, dividing by something is the same as multiplying by a fraction. Get y to the 6th over x to the times 1 over x squared y cubed. What cancels? What does this become? Y to the? So it becomes y to the 3rd over what? Is that right? Hold on, I'm missing something here. It's, oh, we know what we didn't do? I didn't square that right there. So this should be x to the 6th. Sorry about that. So that should be x to the 8th. That didn't seem right. Does that make sense, everybody? Again, are there multiple roots? Yeah, there are definitely multiple roots. Absolutely. Got it. Okay. Any others? Any others from page 3 in particular? Any others from page 3 in particular? You're supposed to pick a few that look challenging. Any others from this page?
On 59,
yeah.
How would you do that?
Ah, how would you do that by hand? Sure. Now, again, would you actually ever type that into your calculator? No. Hopefully not. Numbers that look like that tend to get so big that your calculator freaks out, has an aneurysm, and collapses. What do you see when you look at that? I see 222. That's what I see. What is 666? Yep, to the 4th over. So that equals 3 to the 4th times. What cancels? Which is what? Yeah. Bingo. Now, what about the next one, though? The next one's a pretty good question. What's the... Again, what are you not going to use on 60? Don't use your calculator. How would you go about doing this without using a calculator? There's a couple ways. What would you do first? I don't like decimals. What are you going to do first? Can't really ever hurt to do this. Do we have the same power? So what does that actually equal? Yeah, to the 3rd. So what's that going to be? Which is 8. Absolutely. Another way to look at this, hold on. Another way to look at this, this is not a solution method, but this is more of an exploration. Instead, from here, you can factoring things can be very helpful, especially when before you amplify them with exponents. What is 10? 2 times 20 is 2 times 2 times to the 3rd, right? Correct? So if you distribute that power in, you get 1 over 2 cubed times 5 cubed times 2 cubed, 2 cubed, 5 cubed over 1. What cancels there? And leaving you just with, which is, should you end up with the same answer? You hope so, right? That's just an exploration. Sometimes it's going to be very helpful to break something down into its smallest factors and go from there. Absolutely. Okay, let's open it up a little bit. Any other ones at all on the inside when I see that? I die a little bit on the inside when I see that, right? No. So I like the fact that you brought up a new way to, I find, so you want to do this.
No, I had like Christian signs in between them. Like 6 and 4 plus 6 and 7. I don't even know where. I've seen something, I don't know. Just to make fun of me. But it worked.
No. I'm not making fun of you. I'm giving you a compliment here. I've never seen that before. I've never seen that
That
before.
might be a new, like, law or something. It might work.
Well, let's look. The closest thing I can think of, we'll call this the... Okay, there we go. Ready? No. No. The closest thing I can think of is this. If you have 666, that's the same thing as 600 plus 60 plus 6, right? But even if that's raised to the 4th, can you just bring that 4th power in? No. You can't do that. You have to multiply. So I'm trying to think here. You could do 6 times 111 to the 4th, right? So that would be 6 to the 4th times 111 to the 4th. Correct? And then the fun ends there. Because 111, well, the factors are 11, 2, and 5. There's no nice factors in there. I like this. I mean, I think we should invent new math rules and just go with it. I like that. That's good. I've never seen that before. That's very cool. At least I think I've never seen it before. Just practice. Practice. Okay. Are we good on these? Are we good on these? Are they good on these? It worked again? When I need to see more, let's talk more later about the new rules, okay?
It's working, not with one.
Okay. So there might be new shortcuts. Would you, oh, I thought I clipped it into this. Didn't I clip it in?
You did. Then you started a new page.
Oh, did I start a new page for today?
We already had one.
Are you ready for presents? Presents, here you go. Money, 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 money. We're going to start with a nice amount. Caroline here is going to have $100 in the bank. She's going to get a 10% interest rate. That's wonderful. You hate this stuff? You hate this stuff? Oh, okay. Anyway, time at 0 years, the person's going to have $100. At the end of the first year, we're going to say they have $110. Now, if I said we go for the second year, how much money do you think is going to be in there? 121. How many people think it's going to be 121? How many people think it's going to be 120? How many people think it's going to be something else? What do you think? 10% of 110 or 10% of 100? Ah, what kind of interest did we just compute then? What kind of interest are we computing? Compound interest. Why is this compound interest and not simple interest? Previous amount of, well, the previous amount, but in addition to the original amount, how much? The most recent interest. There we go. You all said that was good. It was like a complete sentence emerging from all three people. You're earning interest on what? On what? Interest. You could theoretically have an account where you put $100 in it, and every year you have $10 out of it, $10 out of it, $10 out of it, $10 out of it, right? Or if you're using compound interest, where does that $10 go? The initial $10 goes right back into the... Okay, instead of taking it out of the account, it grows inside the account. Yes. So you're earning interest on the interest. So at the end of the year, you earn $10 in interest, and where does that $10 get put? Into the account. It never really was there. It grew, and then it got put into the account. And then at the end of the second year, you're earning 10% from the base of $110. What's 10% of 110? 11. What's 11 plus 110? Yes, so what did we just do? We took that, we had 100, and what did we add to it? 10% of 100, right? See, from here to here, we had 110, and we added 10% of 110. So if I wanted to go to year 3, can someone in their head tell me how much it is? Oh, come on. What's 10% of 121? What's 12.1 plus 121? Yeah. How did we... Yeah, 15. No. How did we get from there to there? We did 121 plus 10% of 121. So every year we're earning 10% more based on what's in the account, and we're putting our interest straight into the account. If we took the interest and put it into another account, that would be simple interest. That's boring. We're going to be doing compound interest. Compound interest. Compound interest.
So for simple interest, your account would like change.
No, it would be changing. You like that. You would just gain $10 every year. Your interest would be calculated as 10% of your initial amount every time.
That's simple, but compounds.
Yes. Okay. So let's generalize this a little bit, but with these specific amounts. What does that mean? It means that after 1 year we have $100, but after 1 year we have 100 plus 10%. What's that in decimal? So what is that? That's a. We'll leave it like that for now. After year 2, you have the. Actually, let's simplify it a little bit before I go to year 2. I'm sorry. What's in both of these terms? 100. It's 100 times 1 plus what? 0.1. Okay. So now let's go to year 2. It's going to be 100 times 1 plus 0.1 plus what? The amount from last year times what? Do you agree with that? We're adding 10% of last year to what was in it last year to get the end of this year. Right. What's in both of these? 100 times 1. Yeah. So we factor that out. What are we left with? 1 plus. But look, we have 1 plus 0.1 and 1 plus 0.1. How many of them do we have? So what does this become? 100 times? Yes. So if we did the third year, it would be 100 times 1 plus 0.1 squared plus 100 times 1 plus 0.1 squared times what? 0. You're adding 10% of last year's value. What's in both of those? Oh, right here. So what can we do with that value? Factor it out. And what's left? 1 plus. So what does it turn into? Yeah. Cubed. Okay, so let's try to generalize this formula here. What does that 100 represent? Initial amount. What's the term for that? Anybody know? What's that called? Principal. It's the starting amount. What about this number right here? What's that? Number of what? Years. And that's going to be time. That's T. So this is P, principal, T, time. What about that right there? What is that? Interest rate in what? This is important, everybody. Decimal. Is it kind of important that it's in decimal form? Yeah. For example, 20% is 0.2, right? What happens if I wrote 20? What percentage is that? 2,000. 20 is 2 because 1 is 100%, right? 20 is 2,000%. Is that a slight difference? Is that going to change your account a little bit quicker? Yeah. So what stays the same? That 1 stays the same. What does that mean? If we're compounding yearly, and keep in mind that the interest rate in decimal is always written as per year, just so you don't go insane, okay? Someone give me an amount of money, any amount of money. $4,000 sounds great. Someone give me an interest rate. 2%? Someone give me a number of years. 6, 11, 5. You're wrong. The question I now have is how much money do you have at the end of 6 years if you put $4,000 into an account earning 2% every year, compounded yearly? What do I type into my calculator? Can someone tell me what I type in? 4,000 times what? 0.02 raised to the 6th power. Hit enter. So the question is, Do we earn interest? How much interest did we earn? Okay, let's change it just a little bit. Let's say it's $4,000 at, let's say, 12% for 7 years. Can someone tell me how much? A few people do that just to verify it. Can someone tell me how much we'd have in the account? And all of you maybe should be doing this, and the first couple people can compare. Well, yes, the interest rate and it's long. We're still going to have $4,000. Still going to have $4,000, and it's going to be 12% per year, but instead we're going to compound it every 6 months. And we're going to go for 7 years. So instead of doing it 12% at the end of the year, we're going to do 6% every half year, every 6 months. So the amount is going to be 4,000, 1 plus, what's the interest rate now? Not 12% anymore. If it's every 6 months, it's going to be 6%, so 0.06. And how many times are we compounding it? 14. What does that come out to? Do that on your calculator. What does that come out to? Yeah, it's not quite that you're adding more interest more frequently. What would be a better way to say that in that way? Interest is in the account overall for longer, right? You can think of it as, instead of getting all of the interest at the end of the year, you're getting half of it 6 months early. So that half of the interest, what you just said, so it's very good there, is in there longer. Money over time is money. If I put $1,000 into an account right now at 10%, I'd get out at the end of the year $1,100, right? But if I got that $1,000 at the end of the year, that's only $1,000. Money over time is money. You have more time to earn interest. So by compounding it more often, you earn more money. So instead of doing it every 6 months, let's do it every... So we had $4,000. Let's do it, what do you want to jump to? 12%? How about monthly? And it's 7 years again. So what would that equation be? 4,000 times what? Plus 0.1 to the... Plus what? To the what power? 0.01, yes. Big mistake I just made right there. Thank you. To the what? 7 times what? 12. To the 84th. So do that out and tell me what it is. Someone new, tell me what that is. You got it, Caroline or Claire?
Why is it 0.01?
Because 12 divided by 12 is 1%. 1% is 0.01. Can someone tell me what it is? A whole class of people typing away at their calculator. What is it? 9,000 what? Yep. Anybody concur? Okay, so do we just earn more money? Yeah, pretty good amount more. Yeah, we went from monthly to monthly. We got that. Okay, so what could be beyond monthly? What could be beyond monthly? What? Let's go daily. Let's go daily. Let's just jump to daily. How did we get 0.01? Can someone tell me how we got 0.01 right here? You took 12, right, and divided it by 0.12 divided by 12. So if we do daily, what is that going to be? 0.12 divided by what? Let's use 360, okay, just for standardization. 30 days in a month, 360 days in a year, just for standardization, okay? And what power are we going to raise it to? 7 times? 360. Use 360, use 360. No, it's okay. Use 360. So if you do this, this is the same thing, but now we're compounding it how often? Every make. The more you compound, the more money you should make. So we can keep on compounding hourly. By the second, we'll always make more money. So should we be able to make a ton of money? Yeah, well, let's try it. So we picked, do this on your calculators, everybody. Do 1, 2, 3, 4, 5, 6, 7, 8, 9, and store that as alpha A. Store it as A. So every time you type A, you're going to get 1, 2, 3, 4, 5, 6, 7, 8, 9. So we divided by 360 to get daily interest, right? Correct? We're going to divide by that number instead. Is that going to be a lot more often? That's going to be more than once every second. So on our calculator, we're going to do 4,000 times 1 plus 0.12 divided by what? A raised to the 7 times what? A. If we do that out, look what we got. Did we make more money? did we make more money? How much more money did we make? We made like $1 more. And this is A is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, $1 more. So I'll ask again, can you always make more money by compounding it more often? Yeah. Can you make it as big as you want? No. There's a limit to it. Which kind of interest do you think banks use? How often do you think they compound? Do they compound? What do you think?
Annually.
Nope. Nope. What do they use? Nope.
Monthly.
Nope.
Every 2 years.
How often does money go in and out of a bank? How many times per second at something like Bank of America? Millions of times per second, right? So can they actually, do they compute interest every day? No. Every hour? No. They compute interest instantaneously. What I mean by that is this. What happens as n goes to infinity of this? This is what we've been talking about. What is n? N is the only new thing I added in here. What is n? Number of times compounded per year. Now, this is something I cannot prove to you, but it's true. What number pops up? E. It pops up. This represents, if you calculated interest at an infinitesimal amount of interest every infinitesimal amount of time, this is the maximum amount you'd make. What's the advantage of this? You can you can calculate interest rates as fast as you want. So if you earn continuous interest, let's do this here, it'd be 4,000 times e to the, what's the interest rate? 0.12 times 7. If you do that out on your calculator, 4,000 e to the 0.12 times what? So what's the absolute maximum amount you can make here? It's right there. How close is that to here? What do we get? 0.467833? Look how close it is. You only earned like 7/10,000ths of a cent more, right? Or of $1 more. So like 2/100ths of a cent more, something like that. So it goes up, but does it go up by less and less? Yeah, sure does. It sure does. Growth, that's a great question. Growth and what? Decay. Good job on the transition here. Absolutely. So look at that equation. P plus 1 over, sorry, not 1, R over N to the NT. If N is always positive, right? N is, it's 1 or 12 or 360 or a billion. If R is always positive, it's not P, it's 1, right? 1 plus a positive number is always going to be positive. But if R was negative, N is always positive. If R was negative, then it would be 1 minus something, right? If you multiply something by 1, does it change? No. If you multiply something by something bigger than 1, what happens? It gets bigger. If you multiply something that's by something that's less than 1, what happens? It gets smaller. Same things apply. Absolutely. You can lose money. Absolutely. Okay, so what kinds of questions do you get to face?